Hello and welcome again to our mathematics lesson. We are continuing to look at this topic: length, area, surface area, and volume. In our previous lesson, we were able to look at the surface area of prisms and pyramids, where we said if you're given a prism or if you're given a pyramid, you need first to deduce and come up with its parts or the figures that are making that particular composite figure for you to be able to proceed on and be able to deduce it and completely be able to look for the surface area of the complete pyramid or the complete prism. I'd like to give one example on the same before we proceed on and look at the surface area of cylinders. We are given that a rectangular box is to be covered in material how much is required to cover the entire box? To cover the entire box, if it has dimensions 1.3 meters, 1.5 meters, and 1.9 meters. In this case, we need to understand that this is a prism, and from this particular prism, we are required to deduce that particular prism into the net for us to be able to find the total surface area of this particular figure. So when we express it diagrammatically, it's a rectangular prism. We are told it measures 1.3 meters by 1.5 meters by 1.9 meters. If we were to come up with the net, I say the first thing is to come up with the net of this particular solid. So this base, since it's rectangular in nature, we can open this fling, we open the other one. So this will be 1.3 meters by the 1.5 meters. So when you open this side, we are going to have such, and the length is 1.9 meters. Also you open the other side, it will fall that side. Again, it's 1.9 meters. Then the remaining side, this side will fall this way, the other side will fall on the other side, so we shall have it on the upper region of the base. And the heights are 1.9 meters each. Now we need to come up with the area or total surface area of this particular prism. We have deduced it into a net that we can easily be able to find the area. Now for us to be able to get the area, you need to get the area of this A, the area of B, and because they are going to be the same, we shall just multiply by 2. This one is 1.9 by 1.5, 1.5 by 1.9. So C and D will be the same again. Then we have the bottom part, which is going to be E. Now the bottom will also be equal to this top part, which can be extended in either direction, either that direction or this other direction, and it's going to bear the same measurement of 1.3 by 1.5 meters. So let me call it F. Now if you want to get the total surface area, let's begin with A and B. A and B, that will be twice 1.3 by 1.9 because there are two, plus, let's go to C and D, that's 2 multiplied by 1.9 multiplied by 1.5, plus F, E and F, which will be twice 1.5 multiplied by 1.3. 1.3 multiplied by 1.9 gives us 2.47. When multiplied by 2, this will give us 4.94. We add to 1.9 multiplied by 1.5 gives us 2.85. When multiplied by 2, it gives us 5.70, plus 1.5 multiplied by 1.3 gives us 1.9. When multiplied by 2, it gives us 3.90. So when you add the 3, that will give us 4.94 plus the others will give us 14.54. And because the units were in meters, we shall have square meters. So in a nutshell, this is what we discussed in our last lesson, that if you are given a prism or if you are given a pyramid, you need to first deduce it and obtain the net of that particular solid before you proceed in finding the total surface area. This time round, we want to introduce and discuss how we can be able to find the total surface area of a cylinder. Now, a cylinder can be drawn into 3 different nets, so long as you have the bottom, the top, and that particular curved surface. So if this is our cylinder, we can be able to extract the top and the bottom circles. Then this particular middle part, which is the curved surface, if we were to break along that particular line and levelize or open this particular curved surface, it will end up, or it will give us a rectangle, where the length of this particular rectangle will be the circumference of that particular circle, which can be given as pi d. Height of this particular cylinder is the perpendicular distance from the lower circle to the upper circle, and it remains the same. So if you want to get the width, that is your height. Then for us to be able to find the total surface area of a cylinder, then we need to break it down into this particular net, where we shall look at the areas of the 2 circles, then we add the area of that particular rectangle. And we have said in our previous classes that for you to be able to get the area of a circle, you take pi, you multiply by r squared, that is the radius squared. And now, because we shall be talking about 2 circles, you multiply the whole of that by 2. Then we add the area of our rectangle. In this case, that will be pi d, which is the length, multiplied by the h. Pi d h. So in an eggshell, area of a cylinder, or the surface area of a cylinder, will be given by 2 pi r squared plus pi d h, where d is the diameter and h is the height of that particular cylinder. We can be able to shorten that particular formula since pi is common. I mean, this d is also can be given by 2r. So the surface area shall be given by 2 pi r squared plus 2 pi r h. Because we are having 2 pi on both sides of this particular equation, we can be able to factor them out. This will give us 2 pi into r squared plus r multiplied by h. This is a simplified formula for getting the surface area of a cylinder. Understood that this is a closed cylinder where we have the top part and also the bottom part. Then the curved surface explained as a rectangle. Example. Find the surface area of a cylinder, of the cylinder shown below, giving your answer correct to 2 decimal places. So we are having a cylinder of that form where we are told that the radius is 5 meters. The height of this particular drum is 25 meters. We are supposed to obtain the total surface area of this particular cylinder. In this particular case, we take it to be closed. That is, we have the other side closed, we have this other side closed. So we say that the first thing is to reduce this particular cylinder into its net. And its net, we say that we are going to have the circumference or the circle part above and below. Then the curved surface is going to give us a rectangle where the length of that rectangle is equivalent to the circumference of that particular circular part. So that means that this is going to be pi d, or going to be 2 pi r, and the height remains to be h. Then the circular part, which has a radius of 5, we can be able to get their areas by taking the pi r squared. So surface area of our cylinder shall be the surface area of the 2 circles, which is 2 pi r squared, plus the area of the rectangular part, which was obtained from the curved surface, which is now 2 pi r multiplied by h. We said we can be able to factor out 2 pi because it's common on both. So that will be 2 pi into r squared plus r multiplied by h. That will be 2 multiplied by 22/7 into the radius of this particular cylinder is 5. So that is 5 squared plus 5 multiplied by the length, or the height. In this case, it's 25 meters. So this will give us 44/7 multiplied by square of 5 is 25 plus 15 multiplied by 5 multiplied by 25 gives us 125. So when added to 25, that will give us 150. Therefore, we shall have 44/7 multiplied by 150. This will give us 942.8571. The question requires us to write our answer correct to 2 decimal places. So to 2 decimal places, this shall be 942.86, and because the measurements was in meters, it will be square meters. Note that whenever you give a wrong measurement in terms of the units, then the whole process gives you a null results or 0 results. We are told find the surface area of the half cylinder. Surface area of the half cylinder shown below. Rounding your answer correct to 2 decimal places. Here we have a half it's a half of a cylinder. We are required to generate or obtain the total surface area. Now note that because of cutting that particular circle into a half, we are going to obtain a flat surface, and we are told that the measurements here, the diameter is 4 centimeters while the length is 8 centimeters. So when you chop it off into a half, we are going to have the part which is rectangular, and the rectangular part will measure 4 centimeters by 8 centimeters. Now when you develop these other 2 sides of the 2 ends of the circular or this cylinder, it will give you a full circle, because we have a top, or this side's half circle and the other side half circle. And again, the length of the middle part, which is the curved surface, is going to remain to be 8, while the width is going to be a half of the circumference of this first circle. So if we were to deduce it, we'll have that being this curved surface, then we'll have half of a circle on top, another half circle on the other side, where this is 4 centimeters, 4 centimeters, and then this particular distance from here up to there will be given by a half the circumference of this circle, and that will be a half multiplied by 2 pi r. In this case, we shall have it as pi r. Then the 2 half circles are going to form or give us one. They're going to give us one one circle or one complete circle. Then we must remember to add this one that is down, where, or the cut or the chopped plane, which measures 4 by 8. So for us to be able to find the total surface area, it will be given by a half multiplied by, we are talking about two circles, so this one and this one. So we take 2, we multiply by, to get the area of a circle is pi r squared, but because they are halves, we're going to have a half pi r squared. Then we add the area of the curved surface whose width is going to be a half the circumference of the circle, and that will be a half multiplied by 2 pi r multiplied by this particular distance, which is 8 units. Then we shall add the flat surface or the plane where that particular knife went through, that is 4 by 8. So in a nutshell, this and that will cancel, leaving us with pi multiplied by r, and r is 2 units, so 2 squared, plus this and this will cancel. That will leave us with pi multiplied by 2 multiplied by 8 plus 4 by 8. That will give us 32 square units. So this will give us 4 pi added to 2 times 8 is 16, so that is 16 pi plus 32 square units. 4 pi plus 16 pi, that will give us 20 pi plus 32 square units. 20 multiplied by pi will give us 62.8571. We add that to 32 units or square units, which will result to 94.8571. And because the units were in centimeters, this will be square centimeters. In a nutshell, we have been told to round off our answer to the nearest 2 decimal places. So this shall be 94.86 square centimeters when rounded off correct to 2 decimal places. So we have said for you to be able to come up with the total surface area of this half cylinder, you need to get the surface area first of the 2 cylindrical parts, and because they are half circles, the 2 will result to a complete circle, which can be obtained by this particular formula. Then the curved surface, where the width will be this particular distance, which is half the circumference of the circle, which will be given by a half times 2 times pi times r. Then you multiply by the length, which is 8. Then we must remember to add that particular plane, which is on the bottom, or where that particular knife went through, which is 4 by 8 units. And this has resulted to 94.86 square meters. Example 3. Find the surface area of the cylinders below. Rounding off your answers correct to 1 decimal place. Part 1. We have such a cylinder which is 6 centimeters in length and 2 centimeters diameter. Now we had simplified our general expression for expressing the area of a cylinder into area is given by 2 pi into r squared plus r multiplied by L. Now for us to be able to obtain the total surface area of this particular figure, we need to understand what is our R and what is our L. In this particular case, our L is going to be 6 units and our R is going to be a half of 2, which is 1. So this will be 2 multiplied by 22/7 into square of 1 plus 1 multiplied by 6. This will give us 44 all over 7 being multiplied to 1 by 6 is 6. So 6 added to square of 1, which is 1, will give us 7. So that will be 44 all over 7 multiplied by 7, which will give us 44. Because we're talking in terms of centimeters, that will be square centimeters. This particular formula also, because R is still on the two expressions, we can still be able to factor out or single out one R, so that we can we simplify this particular expression to 2 pi R into R plus L. It will still give us the answer. That was part A. Part B, we have this cylinder which has a height of 10 centimeters and a diameter of 12 centimeters. Again, if you want to get to a surface area, we have said the simplified formula is 2 pi R into R plus H, where H is the height, R is the radius of our cylinder. In this case, we shall have 2 multiplied by 22/7, which is pi, multiplied by the radius. Because the diameter is 12, the radius is going to be a half of 12, which is 6 units, into 6 plus 10, which is the height. Now this will give us 44 all over 7 times 6, or 44 times 6, which will give us 264 all over 7 multiplied by 6 plus 10 will give us 16. So when you multiply 264 all over 7 times 16, that will give us 603.4286 square centimeters. But always refer back to the equation. We are required to write our answers correct to 1 decimal place. So this shall be 603.4 meters squared. Example 4, we are told to find the surface area. Find the surface area of a cylindrical plastic container. Cylindrical plastic container of height 18 centimeters, and with a circle. And with a circle of radius 3 centimeters at each end. And we are supposed to express our answer correct to 2 decimal place. So we have cylindrical container or plastic container which has a height of 18 centimeters and it has a circle of radius 3 centimeters that is on top part and also in the bottom part. We are supposed to express or find the total surface area of this particular cylindrical container. So we are going to first develop the circle in a figure. We have been told that the height is 18 centimeters and it has a radius, a circle at the top and bottom, which has a radius of 3 centimeters. Now we had said that surface area of a cylinder is usually given by 2 pi r into r plus h, where r is the radius of the circular part, and h is the height of that particular container. So this shall give us 2 multiplied by 22/7 multiplied by the radius, which is 3 units, into the radius, which is 3 units, plus the height, which is 18. So this part will give us 44 times 3, that is 132 all over 7. We multiply by 3 added to 18, which is 21. 7 goes there once, 7 goes into 21 3 times. So we shall have 132 times 3, which will give us 396.00 square centimeters. The formula simplifies everything. So long as you can be able to derive that particular formula using the top and the bottom circular parts and the curved surface, which gives you a rectangle. Example 5. We are told that a log with diameter 60 a diameter of 60 centimeters is 3 meters in length. Is 3 meters in length. It's hollow. Its hollow center is 20 centimeters in diameter. Find the surface area we're supposed to find the surface area of the log in square centimeters, including the ends. And the inside correct to 1 decimal place. Now we have a log which I've been told it has a diameter of 60 centimeters and it is 3 meters in length. Now for the purposes of avoiding misconception and confusion, it is important that we first convert these 3 meters so that we have uniform units all across the topic, the particular question. So if this is in centimeters, 3 meters converted into centimeters will give us 300 centimeters, since 1 meter is equivalent to 100 centimeters. So if you have 3 meters, you multiply 3 by 100, which will give us 300 centimeters in length, and it has a hollow center which has also a diameter of 20 centimeters. We are supposed to find the surface area of the log in square centimeters, and this includes those particular ends of that particular log, the curved surface, and also the inner curved surface. Now if this is our log, that is our log, it has a hollow part which goes directly up to the other side, and we need to get the surface area, that is the curved, outer curved surface, also these two ends, and also the interior or the inside curved surface area. We have been told that the radius of this log is 60 centimeters, and that one of the hole is 20 centimeters, while in length it is 300 centimeters. So we are going to find the total surface area of these logs in parts. Let us first look at the surface area of the end parts and this particular outer circular part. Now for the ends, because of this particular hollow part, we need to get the area of the whole circle, then we subtract the area of that hollow part. In this case, area of the circles shall be twice, first because there are two, multiplied by pi r squared subtract pi r squared, where the r is the radius, or the capital R is the radius of the whole log, and small r is the radius of that particular hollow part. So this shall give us 2 multiplied by this shall give us, we can be able to factor out pi, so that we have 2 pi into r squared subtract small r squared. So when you make the replacement, this shall be 2 pi into capital R is 60, so 60 squared subtract small r, which is 20 squared. When you take the square of 60, you subtract the square of 20, you'll get 3,200 multiplied by 2 multiplied by 22 over 7, which is pi. This will result to 20,114.28, which when rounded off will be 0.3 square centimeters. That is the two ends of this particular curve, circular part. We now move to this other side, which is the curved part, and we had said that when opened up, it gives us a rectangle where the length will remain to be 300 and the width will be the circumference of this particular bigger circle. So circular parts, and there are two. We have the inner one and the outer one. So for the inner one, we'll take pi d, that is where d is the diameter of the bigger circle, multiplied by the length, which in this case is 300, plus. Now for the inside, because we also need to calculate or get the surface area of the inside, will be pi d. Now d will be the small radius or the small diameter, which is in this case shall be 40. So that is pi d, again multiplied by the length, which is still 300. Now because we have pi and l which are common, they can be factored out, so that we have pi l into d plus d. that shall give us 22/7 multiplied by the length, which is 300, into the diameter of the bigger diameter will be 120 because the radius was there's a mess somewhere. So for us to be able to get the total surface area, we have said we need to get this area of the circular part, and the circular part has a hole which has a diameter of 20. That means the radius is going to be 10 units, and the other one has a diameter of 60, meaning that the radius is going to be 30 centimeters. So this shall give us 2 pi into 30 squared subtract 10 squared, which will give us minus 10 squared will give us 800. When multiplied by 22/7 by 2, it will give us 5,028.6 centimeters squared. Then for the circular part, there are two. We are having the outside and also the inside. The outside part can be obtained by taking pi d, that is the distance around the bigger circle, multiplied by the length, which was 300 centimeters. We add to the inner surface area, or the inner curved surface, which will have the length of pi small d, again multiplied by by L, which is the length of that particular log, and it is 300 centimeters in this particular case. So we are saying that pi and L are common, hence they can be factored out, so that we have pi L into d plus d, which is going to give us 22/7 multiplied by 300 into the bigger diameter is 60 centimeters and the smaller diameter is 20 centimeters. So 60 plus 20 will give us 80, and therefore the total surface area for the circular part will be 22/7 times 300 times 80, which will give us 75,428.6 square centimeters. So if you want to get the total surface area, you add the area of the circular parts, which was 5028.6, this part, plus 75,428.6, which will result to 80, which will result to 80.457.2 square centimeters. So that will be the total surface area for that particular log. So we have calculated the outside surface area, the inside surface area of that particular hole, then the two ends, which has a hole inside. So it has given us 80.457.2 square centimeters. The last example in this particular area of finding the surface area of cylinders, example 6, we are told that a water trough is in the shape of a half a cylinder. It's semicircular. We are told that the semicircular ends have a diameter of 40 centimeters, and the trough is 1 meter long. Find the outside surface area in square centimeters of the curved surface, and the two semicircular correct to 1 decimal place. So here we have got a trough which has been made in the shape of a half a cylinder, and that the semicircular ends have a diameter of 40 centimeters, and that our trough is 1 meter long. We are supposed to find the outside surface area of the curved surface and the two semicircular ends. So in this particular case, that means that the top part, which in this case is a rectangular part, is not there, or it's open. So if that is the top part, semicircular in nature, we have been told that that is 40 centimeters. The length is 1 meter. That means it is 100 centimeters long. We need to find the surface area of the curved surface plus the two semicircular ends. Now it is important for us to understand that for us to be able to find the total surface area of this trough, we need to get the length. When broken out, this half cylinder will give us a rectangle which is still has 100 in length, and the width is going to be a half the semicircle, or a half the circumference of this particular circle, which has a diameter of 40. So that will be a half times pi times 2r, which will be the same as pi r. Then these two semicircular parts will give us a complete circle. So total surface area will be given by 2 multiplied by these half semicircles, area of the half semicircles, which will be a half pi r squared. We add to the length, or to the area of the curved part, which we have said is going to be pi r multiplied by the length. This will give us pi r squared plus pi r l. And because pi r are common, we can be able to factor them out. That will give us pi r into r plus l. So in this case, this will be 22/7. The radius will be 20 centimeters into 20 plus the length, which is 100. So 22/7 times 20, that will be 440/7 multiplied by 20 plus 100, which is 120. So that will give us 440/7 multiplied by 120. That will give us 7,542.5 8571, but you have been told to round off our answer correct to 1 decimal place. So this shall be equivalent to 7542.9 square centimeters. Consider that this particular formula that we have been able to derive when we're looking at the half of a cylinder is almost the same as how we can be able to find the total surface area of a complete circular container or a cylinder, because for the other one you only needed to multiply this by 2, but because we are talking of a half of the cylinder, then the 2 will cancel off, so that for us to be able to get the total surface area minus that flat surface or rectangular surface, then it is pi r into r plus L, where r is the radius and L is the length or sometimes the height of that particular circular part. So to wind up, we shall revisit that particular formula for getting the surface area of a cylinder. So we say that a cylinder of this nature, which has the bottom and the top radiuses and the height h, we can be able to obtain its net in those particular form. We have the bottom and the top radiuses. To get the area of the top radius, it is pi r squared. Of the bottom radius, it is pi r squared. We are also saying that the distance from here up to here will be given by 2 pi r, and this one remains to be the h. So for you to get the surface area for this rectangular part, you multiply 2 pi r by h. So when you add up this particular surface area to obtain the total surface area, you will take 2 multiplied by pi r squared, which is the two circular parts, plus 2 pi r h. But you can be able to factor out 2 pi r. So 2 pi r into r plus h. In this particular case, h normally takes the form of sometimes the length, sometimes it is the automatic height, as we have seen. Then if you have a half a cylinder and we are only considering the curved surface and the two semicircles at the ends, then you multiply this one by a half, which will give you pi r into r plus h for the total surface area of a semicircular cylinder. Thank you. Next time we shall be looking at volumes of prisms and pyramids. Thank you.